Hi everyone. This video will explain the what are the transient and transmission line. So generally, whatever is discussed in the transmission line, will talk about the steady state case. That means, as the wave is propagating from source to load, there won't be any change when the time changes. And that we whatever we discussed so far. Now the concept of transient is based on this. There is a question in GATE 2015. And what do you mean by transient? Transient means as the wave is propagating from source to load, it will changes as time changes. So generally, the wave will be the function of time and the space. Okay, whenever it propagating from source to load, the amplitude of the wave will changes with respect to the time. That we will see how it will changes and what is the concept of the transient in the transmission line. Right, the basic is whenever the wave is propagating from source to load, the amplitude of the wave will be changes with respect to the time. Now I written here for transient on the transmission line, if the source is generating a pulse of width delta t, that means generally the transients will be occurs due to when the source is generating the pulses, right? So generally we talk about sinusoidal signal is propagating from source to load, right? Generally whatever we discuss. Now what here telling is if the source is generating a pulse of width delta t, then the transients ensues on the transmission line, right? So whenever the source is generating the pulse of small width delta t, then we will come across the transient. Now consider the transmission line of length d connecting a source at one end and a load at the other end. Then I am taking on transmission line. This is the transmission line, fine, and this is the source part and this is the load part. Okay, in the source part we have the source voltage, and the source will have the impedance. Zs is the source impedance, and there is a switch when t equal to the switch will be closed when t equal to 0. Okay, now at this point, right, this is the input of the transmission line, right? This is input of the transmission line. Now at this point, the equivalent circuit of the source and the transmission line will be like this. At the equivalent circuit at source end, it contains source and source impedance, and at this point if you see, the impedance will be characteristic impedance, right? Generally the Z0 is the characteristic impedance which appears at each point on the transmission line. Generally Z0 is defines at each point on the transmission line. So if you see at this point, the equivalent circuit will be like this: source, load, source voltage, source impedance, and characteristic impedance on the line. Now this is given Vs, Zs, Z0, ZL. Now in the above diagram, given that the switch is closed at t equal to 0, and then the pulse generates and transients occurs on the transmission line. So when the switch is closed, right, when the switch is closed, there is a path to generate the pulse, right? Whenever the pulse is going on, it occurs the transients. Now here the pulse will be can be of two types. The pulse width can be narrow pulse or long width pulse. The meaning of narrow pulse and broad pulse is nothing but, see, I am defining here the pulse can be narrow pulse or long pulse. That is, if the pulse width delta t much less than tp, where tp is nothing but propagation time of the source of the wave from source to generator. That is defined as, let d is the length of the line, okay, vp is the phase velocity of the wave. So it's like distance by velocity. Time is nothing but distance by velocity. So tp, propagation time, is nothing but distance by propagation time, the propagation velocity. So if the pulse width is much less than tp, then the pulse is defined as the narrow pulse. If it is much greater than tp, delta t is much greater than tp, then we will call this a long pulse or broad pulse, right? So now we'll see. So it is defined here. Delta t is much greater than tp, termed as a long pulse. Now case 1, I am taking the first narrow pulse, right? When the narrow pulse is propagating on the transmission line, what will happen? So I am taking the again same the circuit diagram, source, impedance, and the transmission line part and the load part. Fine. Now here the switch is closed at t equal to 0 and the pulse is transmitted. See, now at this point, now pulse is generated by the source and it appears at the input of the transmission line. Now at this point the input voltage and the current of the pulse can be defined as Vin equal to generally V plus. Vin is same as the V plus. Now that is equal to, by using the voltage division technique, right, by using the voltage division technique, assume we have the source here, okay, and some impedance here, and again another impedance here, and this is the equivalent circuit, the source end Vs, Zs, this will be like Z0, like we just earlier we discussed the equivalent circuit at the source end. Now at this point we need the voltage, that V in or V plus, both are same. Okay, now by using the voltage division technique you can write V plus is equal to total voltage Vs into the voltage where we are determining the impedance, that is Z0, into by Z0 plus Zs, right? It's like V plus is equal to total voltage Vs into the voltage where we are determining that impedance divided by total impedance Z0 plus Zs, that we define Vs into Z0 by Z0 plus Zs, let equation number 1. Now similarly the current of the pulse, like the current will be defined from the voltage and impedance is I is generally equal to V by Z0. I is equal to V by Z0. Now from this I can write I in or I plus equal to V plus by Z0. Okay, now take this Z0 this side, which becomes Vs by Z0 plus Zs. Then this is the voltage and current of the pulse which is generated by the source and that appears at the input of the transmission line. When it appears at the input of the transmission line, that voltage and current, right? Now the pulse start propagating from source to load. Right, now the pulse has reached the source input of the transmission line. From here to load it start propagating. Fine. Now here again two cases will come. If the load impedance, right, if the load impedance is not equal to the characteristic impedance or the line impedance, then we